All right, people. Greatest common factor. In our Google Classroom, under supplemental instruction, I've posted a few sheets for you to take a look at to give you an idea of where to start with this, with divisibility rules. So the divisibility rules show you which numbers can be divided evenly based on like whether they're even or how to find the little tricks to make that part of the process easier. So I always start with 2 if it's an even number. If the number ends in 0, 2, 4, 6, or 8, you can divide it by 2. If it's not an even number, then I go to see if it ends in 0 or 5, in which case it's divisible by 5. Or I check if it ends in 0, it's divisible by 10. And then I go to 3, and if the sum of the digits, meaning if you add the digits in the number together, is divisible by 3, then the whole number is divisible by 3. So once you learn some of these rules, starting your factor tree gets a lot easier. So I've posted that. I also posted this prime number chart. It shows the numbers, I think, up to 100, that are prime numbers. So this helps you with knowing where to stop your factor tree. When you are trying to find the greatest common factor, you want to do a factor tree for each of the numbers that you're given to find the greatest common factor between. And when you make those factor trees, you stop with the branches at once you get factored down to a prime number. So you can see highlighted in green some prime numbers up through the number 100. 2, 3, 5, 7, 11, and 13 are about as high as the questions are going to ask you to go. So just kind of, you'll get the hang of it, memorizing some of these prime numbers as you work through some of the problems. But if you're looking at your factor tree and you're like, I don't know if 13 is prime, maybe look up this chart really quick just to confirm. You can also Google, is 117 a prime number? It will tell you yes or no. That can be convenient as well. All right, there's a little video showing you a factor tree, but right now I'm making you a video to show you some greatest common factors. So I've put myself on this level, this lesson in Acellus. So my first 2 numbers I've been given to find the greatest common factor of are 18 and 54. Now, a factor is a number that fits into another number evenly. So like off the top of my head, I know 18 is divisible by 2, so 2 is a factor in 18. 18 is divisible by 3. If I do 3 times 6, I get 18. So 3 and 6 are also factors in 18. We want to find the biggest number, the greatest number that fits into both 18 and 54. So we can do that by doing factor trees. So I'll get my piece of paper and pencil that are electronic. I'll start my factor trees for both numbers. 18, 54. Okay. 18 is an even number. I can divide it by 2. 2 is a prime, I'm going to circle it. 18 divided by 2 is 9. 9 is not a prime number. 9 is divisible by 3. If I do 9 divided by 3, I get 3. 3 is a prime number. I'm going to circle them. Now I'm done with this factor tree. All of my branches end in prime numbers. 54 is divisible by 2 because it's an even number. 54 divided by 2 is 27. 27 off the top of my head is not even, doesn't end in 5 or 0, so I can't divide by 2 or 5, but I know it's divisible by 3 because 3 times 9 is 27. So 27 divided by 3 is 9. 9 is not a prime number. 9 is divisible by 3. If I do 9 divided by 3, I get 3. Remember that division is the opposite of multiplication. So just like I divided my way down to the bottom of this factor tree, I could multiply my way back up if I wanted. 3 times 3 is 9, 9 times 3 is 27, 27 times 2 is 54. 54 divided by 2 is 27, 27 divided by 3 is 9, 9 divided by 3 is 3. You get the idea. So here we've got our factor trees done. We're down to our prime numbers for both factor trees. Now to find the greatest common factor, I have to look for matches in the prime numbers. So here I have one match. I have a match of 2's. So I'm going to write down just 1, 2. I'm going to put a multiplication symbol. I have another match in my branches. They both have at least one pair of 3's. So there, I'm going to write times 3. Another multiplication symbol because I have another match of 3's. So I'm going to write a number 3. If you want to, you can cross off your matches as you write them to keep your mind organized or whatever. You can see that there's a 3 left. It's not a match. This other factor tree does not share it. So we're done listing the prime factors that exist in both trees. When we've finished that, we multiply the prime factors together. 2 times 3 is 6 times 3 is 18. So 18 is the greatest factor that fits into both 18 and 54. 18 fits into 18 one time. 18 fits into 54 3 times. Either way, they fit in an even number of times. 18 is my answer. Okay, 27 and 45. No, don't save. 27, 45. Okay. 27 is not an even number. It doesn't end in 5 or 0, but I know it's divisible by 3. Because 3 times 9 is 27, so 27 divided by 3 is 9. I'm going to circle my prime number 3. 9 is not prime, so I can divide, but because I can divide it by 3 and get 3. Okay, I've factored that one down to its primes. I'm going to move on to the next one. 45 ends in 5, so I can divide it by 5. 5 is a prime, so I circle it. 45 divided by 5 is 9. Just like we did over here, 9 is divisible by 3. If you divide 9 by 3, you get 3. Okay, now we look to find the greatest common factor. We look for matches. Here, we've found a match of 3's. We've got 1 3. Oh, yikes. Okay, times. They don't have a matching pair of 5's. They do have another matching pair of 3's. Times 3. So 3, if I do 3 times 3, I'm going to find my greatest common factor, which will be 9. 9 fits evenly into 27 3 times. It fits evenly into 45 5 times. 9 is the greatest common factor of 27 and 45. Okay, what's the greatest common factor of 28 and 70? 28, 70. They're both even numbers, so off the top of my head, I'm probably going to divide them both by 2 to begin with. But we'll do one at a time. I'm getting ahead of myself. 28 divided by 2 is 14. 14 is an even number, therefore I can divide it by 2. Circling my primes as I go. 14 divided by 2 is 7. 7 is a prime number. What was that number again? My penmanship on this thing. Okay, 70. 70 divided by 2 gives me 35. 35 ends in 5, so I know it's divisible by 5. If I do 35 divided by 5, I get 7. Now I factored down in my primes. I look for matches in the factor trees. They've both got a 2. So I write that down. 2. This one has a 2. This one doesn't have another 2. This one has a 5. This one doesn't have a 5. But they both have a 7. Okay. Now I take my matching primes and multiply them together. 2 times 7 is 14. I have my greatest common factor between 28 and 70. Okay, 25 and 75. Here, I'm going to cheat. So if you know that the smaller number fits evenly into the larger number, that's your greatest common factor. I know 25 fits into 75, and you're not going to find a larger number than 25 that fits into 25. So 25 is going to be my answer. If I wanted to, I could make factor trees. But if you've got the mental math down, then go ahead and skip that part. Okay, 16 and 48. Again, I think 16 fits into 48, but let's just say. I don't know for sure. So I'll do my factor trees. Both even numbers, 16 divided by 2 is 8. Even number divided by 2, get 4. Even number divided by 2, get 2. 48. I'm gonna, instead of doing it by 2, I'm gonna throw in a wild card here, because I know 6 times 8 is 48. So I'm gonna start my factor tree like that, because I can. 6 isn't even. If I divide it by 2, I get 3. 8 is an even number. We just did it over here. It's going to be the same thing. 8 divided by 2 is 4. 4 divided by 2 is 2. Okay, now I look for the matching primes in both factor trees. Okay, I've got a matching pair of 2's. I'll write down a 2. I have another matching pair of 2's. I'll write down another 2. I have another matching pair of 2's. And another. Okay, they don't have a matching pair of 3, so we don't include that in our list of prime factors to multiply to get our greatest common factor. 2 times 2 is 4, times 2 is 8, times 2 is 16. And just as I suspected, 16 is our greatest common factor. I think it fits into 48 3 times. Yep. What is the greatest common factor of 36 and 60? Okay. Again, you could start with dividing them by 2 if you wanted to. You don't have to. You just have to, you can just think what times what is 36. Off the top of my head, I get 6 times 6. And then those are not primes. I know that 2 times 3 is 6. So 6 divided by 2 is 3. Same for this 6. Factor it down to its primes. Okay, off the top of my head, when I think of 60, I think 6 times 10 equals 60. So I'm going to write that. 6 and 10 are not primes, so I've got to keep drawing my branches. 6 is divisible by 2 and 3. If you do 6 divided by 2, you get 3. 10 is divisible by 2 and 5. 10 divided by 2 gives you 5. Okay, now I look for matching prime numbers in both trees. I've got a pair of 2's. Now it sounds like I'm playing poker. Got a pair of 3's. Got another pair of 2's. And that's the last of my pairs between the two trees. 2 times 3 is 6 times 2 is 12. 12 is my greatest common factor in 36 and 60. 12 fits evenly into 36 3 times. 12 fits evenly into 60 5 times. 24 and 32. Okay, let's do this file. If I'm driving you crazy by not doing the 2, if it's an even number, I'll go back to that. So we've got 24 and 32. So the basics without even thinking of the multiples, even though I think 6 times 4 is 24, or 4 times 8 is 32. I'm going to say it's an even number. We're going to start by dividing by 2. 24 divided by 2 is 12. 12 is not a prime. 12 is an even. I can divide it by 2. I get 6. 6 is not a prime. 6 is an even number. I divide it by 2. When I divide 6 by 2, I get 3, which is a prime number. I'm done with that factor tree. 32, I think it gives me like 5 2s. I've only done this a few times. 32 divided by 2 is 16. 16 is an even. Divided by 2, I get 8. 18 is even. I divide it by 2, I get 4. 4 is even. I divide it by 2, I get 2. Sure enough. Got 2 to the power of 5, or 2 times 2 times 2 times 2 times 2 equals 32. All right, I look for my matches. I've got a matching pair of 2s. Oh, I changed my color. Wild. 2. And another matching pair of 2s. Another 2. Another matching pair of 2s. 2. And the 3 doesn't match, and there isn't another pair of another 2 in this tree. So I've got the prime factors that match in both trees, and I multiply them together. 2 times 2 is 4 times 2 is 8. 8 is the greatest common factor between 24 and 32. 8 fits into 24 3 times. 8 fits into 32 4 times. All done.